We're now going to look at the random number generation feature in Excel. If you go to Data in Data Analysis, there is an option, Random Number Generator. Now, this is very much an extension of, like, we'll do this, random between, we've done this a lot, 1 and 10. Get a random number, between, I don't know what that is, 1 and 10. But you can create random numbers that have a certain shape. And so if we went to the random number feature, you can, the distribution that you can pick are all of these. We're just going to work with the normal, though there are some extensions that you could do. So I would like to make a list of data that I would like to make a column of data that represents just the major league. I have a feeling that when we look at all the pitch speeds, we have the middle school, we have the high school, college, and we have the major league. And so I would really like to narrow in on this major league part. Let's first find, if we're just doing an analysis of Major League Baseball data, I just want to say, what is the max speed? What is the min speed? And get those written down. And so we could say, we've done this before, we want the maximum. And we want the maximum, but only if column A is Major League Baseball. So you write the logical test, so column A is Major League Baseball, then you write the value, and we want to look at the value, which is the value in B, and we want the maximum of B. Oh, I forgot a parentheses. Yes, add it. Okay, and so we have 96, and for the minimum for the Major League Baseball, I copied and pasted, and we have 89. So the min is 89, the max is 96. Let's make some, let's actually then make a Major League Baseball histogram. So if I go to data and we go to our data analysis, let's practice with the histogram, just the histogram. So I am going to take, let me get out of here. Let me take the bins that go from 89 to, we'll do 88, 89, and we'll go all the way up to like 97. Okay, so we'll use these bins. There aren't many of them, so I'll put every number in there. Now let's make a histogram. So the data that I want is the data that comes for just the Major League. And the bins will be right here. We do have labels, and let's put the output on like H19 is fine. Okay, so here we have the graph of just the Major League. I'm going to real quickly double click on the bars. I want to get that gap width to 0, and I want to get some, go to the paint, I want to get a little border so I can differentiate the bars. Let me see. need to click on a color here. All right. Also, I don't need these categories or that category. Okay, real quick, I'll just clean this up. These are the pitch speeds in miles per hour. That's the frequency, which is a synonym for count. And these are the pitch speeds for Major League Baseball pitchers. Okay, so we see here this very normal shape, mound shape. It's often called the bell curve, and that's what a normal distribution is. So for Major League Baseball, let's find the mean, because a normal distribution is determined by its mean and how spread it out it is. The measure of center used for the normal distribution is the mean. The measure of variation is the standard deviation. So we want to include, we want to add to these statistics. I'm going to copy and paste this. But here we want to have the average. What is the average? And here I want to have the standard deviation. The standard deviation is how spread it out it is. We'll use sample standard deviation because we have a sample. Okay, let's take this down to just one decimal point. Very good. So now we can create some data. So this is the pitch speeds for Major League pitchers that were observed. Whoops. Now we're going to make some simulated speeds in miles per hour. And we'll do that by using our mean and our standard deviation. So we'll go to the data, we'll go to the data analysis, and we are going to do our random number generation. We only want one variable. Let's simulate 100 of them. So we'll have 100 rows of data, normal distribution, and I'm going to put in our 92.7, and I'm going to put in our 1.3. You need to choose a random seed. Random number generation simulators are actually based on random seeds. Put whatever you want there. Let's put this output, let's put it in F2. And there we go. We have all of our simulated speeds. And let's go ahead and graph these. So we will insert a histogram. We're going to use our F, so I'll click there, Control-Shift down. We're going to use the same bins. We do have labels. And let's put the output in like H30. All right, here we go. Let's move this down. And so now I can make this a little bigger. Again, I'm going to make it histogram-like, so double-click there and get the gap width down to 0 and get those separations in there for the borders. Okay, I don't know. I guess I didn't click them all. We have our line, our fill. Let me go back. Did I do it? Somehow I keep not doing everything. So we're going to click here. We're going to go to paint. We're going to go to our border. We want a solid line. Yes, That's good. Huh. It's just now picking up everything. Let me see. Isn't it weird how you do something a gazillion times and then you click on the wrong thing? I don't know, it's almost like something's weird on my screen. I'm just going to try it one more time and then I'm going to take a break. All right, there. Don't know what I did different. Very good. So here we have our pitch speeds for Major League Baseball pitchers, but we have simulated. And we can see that the shapes of the histograms are very much the same. And so this is a nice thing that can be done in statistics sometimes when you have a distribution like we have of speeds, you see what the shape is, and then you can simulate random values based on that distribution.